Let's learn about mechanics and heat. I'm just kidding. This is about module 1, 2, and 3. Let's get with the basics with module 1. We got sig figs, we got conversions, lengths. Obviously, sig figs are used to identify the unidentifiable. Basically, it's just used for give that really long equation of yours, and then you see a bunch of numbers in your calculator. You use sig figs to identify what's your answer, or you could just round off. That's also a thing. And also, we got distances, volumes, we got forces, we got different kinds of forces and measurements. We got newtons, we got mass, force, capacity, time, metric systems, we got volumes, all that good stuff. So obviously, we got to present one problem for module 1. So obviously, module 1, let's choose the hardest. You take, so I don't forget because I got Alzheimer's. So let's just say a tank has 20 feet. So basically, we got 20 feet across, and then it's 5 feet wide. 5 feet wide. And now it is 6 inches deep. 6 inches deep. No, 6 feet deep, to be precise, right? Now, how do you find the volume? Easy. Just measure it. Boom. 300. Okay? 300 meter cubic feet is the answer. Is the amount of volume that tank can hold. Now, obviously, of the cylindrical ones, right? So it's easy. You just need to find the radius, find the length. So you need to find the radius, then find the length of the bottle, and then find the inside groovings. Simple. Same as always. Just apply it, and then you'll have cubic meter feet. It'll be easy. So let's move on to module 2. Let me open up this file. Module 2. It's all about displacements and distance. Simple enough. Distance, displacement. Distance is a measurement of amount of feet or whatever unit of measurement you have traveled. Displacement is basically where do you come from, where did you go, Karanai Joe. Obviously that was a joke. Displacement is how far an object in front of his position and current position. And obviously we got different forms of displacement. We can use tan, we can use sin, we can use cos to find the degree of how much you've displaced. So we take a southeast and then take that number and put that in, and we can find the amount of degree. But let's just not talk about that now. So obviously we got average velocity. So in velocity, the type of things you need to worry about are speed, average speed. We got velocity and average velocity, and instantaneous and average velocity. Oh boy, you're gonna love this. So average velocity is basically how regularly do you run on the road. Instantaneous is basically why did you go fast and how did you go fast, obviously. And now for acceleration, simple enough. Thing go vroom, go fast, easy to understand. Do not make me elaborate this further. So average acceleration, what is your average vroom time? How fast do you go vroom vroom? And how average vroom vroom that is. What a straight path rest of 75 kilometers per hour at 5 seconds. Determine the average acceleration. Obviously, I am 0 kilometers per hour. Final velocity, the second velocity is 75 miles per hour. A is blank, so we don't know what the acceleration is. The time is 5 seconds. So the solution, check the given data, whether if it's the same unit, and if it's not, convert it at first. So 75xx to 20.83 meters per second. And then after the conversion, proceed to the findings and the unknown of the problem. We get 4.17 meters squared. Simple enough. Thank you. And we got motion of constant acceleration. The variables here are elapsed time, acceleration, initial time, initial position, initial velocity, and final position. Basically, how far you have displaced. If you were paying attention, move displacement is where you go from point A to point B, but you got lost, so you're displaced. Simple enough. And also, one final thing, final velocity, because you gotta know how fast you've been rooming around. So kinetic equation, we got that's a given. You know what's not complicated? Gravity. Let's talk about gravity. Obviously, things go fall. Duh. If you believe that the Earth is flat, you are obviously Earth is round. And what's with Earth? We got gravity. So if you just let go of gravity, the force applied here, not counting the weight, is 9.8 meters per second squared. So just calculate that into anything. Remember, 9.8 meters per second squared. Tattoo it on your chest. That's how fast the gravity works here. Thank you. So that's your acceleration into anything that you apply to gravity. Thank you. So free falling objects are objects that are free falling, not due to gravity, not due to its weight, not due to anything. It just simply falls, and that's why it's called a free fall. It doesn't need to rely on aerodynamics or how heavy or so free falling objects do not encounter air resistance. Yet all free falling objects are 9.8 meters per second squared. I already in free falling objects, 9 meters per second squared is always in a negative sign because we're falling down, and we're using graphical positions to identify if it's going left, right, up, down, because math. You already get the idea. Positive y, positive x, negative x. You've get the idea. It's simple math. So if an object is merely dropped, the initial velocity is 0 per second squared because you just let go of it. And at the time of the velocity, height symmetry for a fallen object is projected towards when then it falls down perfectly to its own vertical direction. However, the sign of velocity changes to positive or negative due to its direction, only increasing as its absolute value since absolute value since the scalar quantity. Schematic equations derived from previous lessons will be submitted with the following. X is substituted by the variable of y. Since the direction of motion is in the y-axis, A will be substituted by g, ground force, obviously, duh. 9.8 meters per second, since the acceleration is due to the gravity as a constant, 0.8 meters per second squared. So we take 1 second, and then we take 9 meters per second squared. Now put this in your calculator, right? Because this is going to be important, because I know you got your calculator, right? And you input in 9.8, and obviously don't put the negative there because it already is negative. At least you can remember that negative is applied to gravity. So 9.8 meters per second squared is erase the 9 meters per second squared and just erase ms2 and then add in 1 second. So to be more frankly, it's supposed to be times 1.0 because we're fancy like that. And then input the time, 9.8 meters per second. So how fast is falling at 1.0 seconds? It's 9 meters per second. That's a heavy. So obviously in times 2 that you'll get 19.16, and then you go to 3, 24 I can't see, 29.4 meters per second. Yeah, that's the solution. Here in the other equation, we're learning how fast. Here we're looking how much distance. So obviously we got in solution 1, we take none of that, and then we have negative 0.90 meters. That is a crazy amount of distance, and it doesn't need to be converted because meters per second squared doesn't need to be cut in half, because honestly meters per second squared, and if you put that into seconds squared, it's just gonna be 4.9 to be exact. And then obviously you just take that, apply it to the same formula. Wondering how do you calculate that? Well, that's pretty simple. Apply the same things, but you do it oppositely. You got gravity, so you got to remember to put a negative on that to represent the values that it's going down. Now if it goes positive, guess what? your brain is going slow motion, yeah, you're going upward, you're high, bruh. So you just go up, it goes positive. If it goes down, it goes negative. Apply the previous formulas that I've shown you earlier, and then there you go. Please. Hold up. Man, this module wide. Alright, so module 3. This is the most horrible. So, vector can be represented using arrows. The length of the arrow represents the magnitude of the vector, while the direction represented is orientation of the arrow. For vectors, would be the longer magnitude of like m, kilometer, mile, pound, newton. So obviously, these are either distances or forces, or both. Who knows? So that's why you need to know where they're going. The miles north. Why? I don't know. He has no sense of direction. For this, how far this person is starting point, we'll take 19 miles up. 19 miles east, so that's going right. North is going up. So we get this, and we get this, and then we have, and then obviously look, the module already says to measure D1 and D2 by translating it to 90 centimeters to make it easier for your tiny brain. So 90 centimeters to the right, and then 5 centimeters upward, and then correct the tail of the D1 and then the D2, and then wait, I scrolled down on accident. I was in the middle of explaining. Measure the angle with respect to the horizontal, and by using a protractor, answer D1 is 10.3 centimeters and 29 n degree north of east. And then finally, read the thing for you. So what I was trying to explain is that you're using the Pythagorean theorem to basically know where the heck you've been. So you take your sin or whatever problem you're given. Obviously it's not gonna be easy, so you're gonna take your sin, your cause, your STS, your cot, whatever. You remember where they are, you use that formula, you get the degree, and you total the distance traveled by using the Pythagorean theorem to find the other side. And then after that, bing bang boom, you travel that direction in that degree in that length. Math is